We are recording. Let's get the slideshow set up. Convert slide. Go from there. First, I want to know, any questions for anything we've covered so far? Any? None? Okay. All right. I'm going to start modeling today. No. Okay. Mathematical modeling today. Okay? All of you have books or not? Do you? Okay. You got one, Tyler? Okay. Well, here's a table here. This table shows depths in feet of the water at the end of a dock at various times during the morning, where T is equal to 0, corresponds to midnight, and then, of course, T equal 12 would be noon following that midnight. Okay? And they've taken depths of the water at these 1, 2, 3, 4, 5, 6, 7 times. Okay? Now, the first part, and I wish I could keep this, in fact, I think I will keep it up. The first problem, and for those who don't have a book, it's 4.5, page 305, top of the page. Example 7. Okay? A says use a trigonometric function to model the data. Okay. Now, how would we go about doing that? A trig function. Which trig function do you think you might want to choose? Let's not use cosecant, okay? Or secant. Huh? I thought you might, okay. He's sort of here. I didn't say it today, but he is sort of. Okay, never mind. All right, now. Second? Sine or cosine, either one. We'll use sine, okay? So, what is our most extensive representation? And here we have, Jasmine Noble. No, she'll say half the class, not quite half yet. Okay? So, we'll have depth as y is equal to, now the sine function, y'all said sine. Okay? Now, fill in the blanks. What are the various parameters we could have associated with that sine function? What we've been doing this whole section. Various letters we can associate with that sine function. Where does the alphabet begin? A, okay, A sine. B, now I like to do it this way. The book does it, but I'm going to do it this way. And then your independent variable is T. T minus C plus D. There is the most general form we have of the sine function, where A is related to, also starts with A. Amplitude, B is related to, period, C is related to, up or out, C is related to, phase shift, and D is related to vertical shift. Okay? Phase shift is a horizontal shift, vertical shift is up and down. Now, the data are representing, of course, the y. The t is the independent variable. We'll fiddle with that a little bit later. Which of these do you want to... Man, I forgot to go open the door. Okay. Try to do that every morning, but I was running a little late this morning. All right. Looking at the data, what do you think you can pick out of here? Looking at the data, what can you pick out? What do you notice when you look at the data, especially the y values? Say again? What impresses you about that? Anything? Say again? Nothing. Okay. When would you want to jump off the end of that dot? 10 in the morning? Why not? What's that? I can see now this is a 9:30 class. That says something, doesn't it? The Jorians here, that's what it says. Okay. Looking at the data, what do you notice about 10 o'clock? Say again? 0.1, and I can't remember what these are measured, in feet. 0.1 feet of water there, I don't think I want to jump into that. Okay? I'm probably going to be stuck in the mud if I do, and maybe injured or whatever. Okay, depends on if it's rocky or muddy. So that is what would you say the 0.1 is among these numbers? The minimum value. Okay? Let's go to another extreme. Say again? 11.3 would be a maximum value. Now, one thing we could do is go on and plot the data. And I think the book probably does that, but I just didn't bother to do so. I don't have very much room. And what do we say, especially when we talk about trig functions, sine and cosine functions, what does the max and min tell you? Say again? Okay, we got that here. All right, good deal. 4, 6. Jordan's an outlier. He's over on that road. All the rest of you on one road. Okay, good. Okay. Now, what do max and min tell you? Especially related to something, any one of those variables. Does that have anything to do? Well, I saw. You tell me. Which one of those variables somehow could you relate to the max and the min? A little louder. Okay. The amplitude. Yes, the amplitude is related. How is the max and min and amplitude related? Okay. Let's just pretend we have a sine function here. And this is anywhere near the thing. In fact, that's totally wrong, so let's make something a little better than that. Okay. Okay, we don't have that much. But what does this tell you? How are those two values related to the amplitude? Okay, from what? Okay, say again? Okay. Okay, they do have something to do with period. It's a little more involved. Amplitude is, I think you're on the money with amplitude here, but let's go back to just a plain old sine function. Okay, starts at 0, does this. Now, what does this and this relate to the amplitude? The max and the min. Say again? Okay, that's the range of the function, and how is the range of the function related to amplitude? Say again? Okay, now, let's go to this one. Let's not mess with this one yet. The amplitude on this one, what would it be? Would it be this value, what value would the amplitude be? Okay, it's the absolute value of A is the amplitude. That's correct. Okay, and that is always positive. But how is that related to the distance between the max and the min? Okay. If this was just a regular sine function, sine x, say, not t, but x. Okay? Now, where does sine go between? You mentioned its range. What is the range of sine? Okay, it starts at 0. It goes up to just a regular old sine function. Where does it go? If this was my function, what would be my amplitude of that function? What is the A here? 1. Well, I feel like a dentist, okay? Pulling teeth here. It goes up to 1 and then down to -1. Up to 1, down to -1. That's your max min, right? Okay? Now, if all you knew were max min, so you say your amplitude is 1. Well, what's the difference between +1 and -1? Okay. What does difference mean? Subtraction, right? Okay. So the +1 minus a -1. 2. All right. So the difference between the max and the min is twice the amplitude, isn't it? Because you go up so far, but then you go down that same far. The far up or down, that's your amplitude. It's the distance above or below your equilibrium point. Okay? So, let's get back to these. What's the difference between those two? Math is that hard, is it? You know it has a 11.2. And that's going to be, how's that related to amplitude? Say again? Someone said something. What did we say that this was? Twice the amplitude. So this 11.2 is twice the amplitude. So let's write that down. 11.2 is equal twice the amplitude. What is your amplitude? Say again? You can even use a calculator if you need it. The math's not that hard. What is it? Okay, there's an equation. 11.2 equal 2a. What is a? Say again? How do you get a? Is this 113? Say again? Divide both sides by 2. Very good. Okay, and that gives you a is equal to 11.2 divided by 2. Oh man, reaching for those black boxes. Not 5.6. All right, it's 5.6. So the amplitude is 5.6. Okay, so if we're going to have the amplitude of 5.6, what you reckon our A is going to be? 5.6. And I agree with this because notice here, from where we're beginning, it's going up and down just like the sine does. So we're going in the positive direction. So yeah, we'll use 5.6. So we've got our A of 5.6. And that's measured in feet, by the way, but we don't have to write that in. But I'm going to write it in now just to keep it in mind. Okay. Now, What's another thing you notice right now? I didn't plot the data, I just sort of drew it in somehow here. It doesn't go quite as far as I did there. But let's just imagine that I was right. This was 3.4 here. That's when t is equal to 0. So this is the t-axis. This is a 11.3 up here. This is 0.1 down here. I probably don't have this to scale or anything. Okay. Now, which one of these other parameters, we got the A, B, C, or D, is sort of related to that, our graph there. Especially, I think maybe the max-min can help. Second? The D, I agree with you. How is D related to our max and min? Okay, it's going to tell you a starting point, and what you did in this problem right here. It's 0 because you're going up as far as you're going down. It's only when you either elevate this or drop it that the D comes into the picture here, right? And what have we done here? Moved it up, okay? And we've moved the equilibrium point up somewhere, I'd say around there. How can we determine? How is the equilibrium point related to our max and min? How is it related to the max and min here? Yes, it's exactly in the middle, which would be the average of the two, wouldn't it? So this time, we're going to take our max and min and not subtract them, but add them. And what does that give us? 11.4. And then the average of that, those 2 points would be black boxes. 5.7. So now we've got our D. 5.7. That, by the way, is also in feet, but we really don't need that too much yet. Okay. So we got we got half of them done already. We've got our model really shaping up here. Now, something I think that Chevette said, it has to do something with the starting point. Since our 5.7 is our equilibrium point, okay? That's somewhere up here, isn't it? Above 3.4, okay? So, I'm just going to pick, again, may not be to scale, but this is our 5.7. That's what that tells us, okay? Where the equilibrium point is, the D, that's what it tells us. So that means our sign, which usually starts at 0, is now going to be starting here. So evidently we have what would be the distance between here and there. What would that be? It's a horizontal shift, isn't it? Which one of these parameters relates to that? Say again? The what? You may have said it. I can't hear what. C. Exactly. So the C is going to relate to that phase shift. How far over is that? Okay? And I don't know that we are there yet. Say again? Okay. Let's see. The other thing we're missing is B. Maybe it would be better to take care of B first. Now, again, B is related to what? Period. Okay? Now, up here, where would the period extend to? Tell me to stop when I've reached one period. That's a period? No, that's half a period. There's one period called, it needs to be the same value, but it needs to be going in the same direction. Okay. Now, So this would be one period, right? That would be half a period. What would this be? That's half a period. What's this? From the max to the min. Okay. Back off it. This is one period. That's half a period. From here to here, that would be a quarter period, right? And from here to here would be a quarter period. So there to there would be a half. So there's half a period from, now the period is related to the time, the horizontal axis, okay? That's the x-axis, except now it's the t-axis. So the difference between 4 and 10, that's going to be, how much is that? 6, and that's going to be half a period. So what's your period? 6 is half a period. What's the full period? 12. Okay. Now, how is B related to period? Something you really should know. We said B is related to the period. How is it related? The period is, what was that? Oh, y'all been working those homework problems like crazy, haven't you? Yeah. I can tell. It's right on the tip of your tongues. What is period? 2 pi over b. Excellent. Okay. We're looking for b. You just told me what the period was, didn't you? What did you tell me it was? 12, and that happens to be hours. So the 12 is equal to 2 pi over b. Multiply both sides by b, gets rid of the b in the denominator, which I didn't like, and divide by 12. And what is our period then? 2 pi over 12, which is pi over 6. That is b. Okay? So our b here is pi 6. Okay? Now, how are we going to get that c? Okay? That's the only one we're missing. How far from 0 is it before we reach that? That is our offset, that's our C, our phase shift, whatever you want to call that. Okay? That would be the place where the function should equal 5.7, shouldn't it? Because that's our equilibrium position. That's right. Okay, now looking at this, 5.7 would be reached somewhere between 1 and 2 hours, right? Okay. So I know how I want to do it, but let me make sure I don't deviate too far from what the book does. Oh man, they use cosine, so that's that changes things a little bit. So what we want to do, we want the y to be 5.7 is equal to 5.6 times the sine of pi 6. Make sure they did that right. Okay, someone who has a calculator, boy, they did it so strangely here. Someone do pi divided by 6 and tell me what it comes up. Yeah, I'm pretty sure that's right. Say again? Yes, okay. They did it the same way. Okay. T minus C plus 5.7. No. I think I mislabeled something. Yeah, no, that's right. Yeah. All right. If you subtract 5.7 from both sides, that gives you 0. So 0 is equal to 5.6 times the sine of pi over 6 times t minus c. Okay, we're looking for c. First thing I'm going to do, divide by 5.6. Okay, and guess what? Since that's 0, that goes away. So now we have sine of pi over 6 times the t let's see. Okay. All right. Now, where is sine equal to 0? When this thing's equal to 0, right? So that says that this probably isn't the best way to go about getting it. Period. Let's try that. We need a t to put in there, and that's where I'm having some difficulty here. What time would that be true? Okay. Okay, how they did it was the high tide happened right here. Okay? Shucks. Sorry about that. The low tide was here. Halfway between that was 3 hours, right? Okay. So this point right here was at 3. This was at 4 o'clock. This was at 10 o'clock. So this was at 7 o'clock. Okay? Dumb me. Okay? Subtract 3 hours from this and you got 1 o'clock. There's where your t is. So the t is equal to 1. Or c is equal to 1. Okay? Okay. Trying to do it the hard way, it's much easier to do it this way. Your maximum was at 4 o'clock, your minimum at 10 o'clock. So that meant this 0 right here was at 7 o'clock, right? And this is exactly half a period from your offset, right? Well, this is 6 hours, 6 from 7 is 1. So 1 o'clock is when you reached your, that was when you were at 5.7. Okay? Okay, yeah, well, it's because you have half a period between here and here, right? That's 6 hours between 4 and 10, okay? And a quarter of a period would be between here and here, right? So a quarter of 6, did I do that right? No, I'm sorry. Half the period is 12, and a quarter of 12 is 3. So 3 hours before this would be 1 o'clock. So this would be at 1, 4, 7, 10. Okay? We just don't have a 1 o'clock in here, but we have our 4, 10. That's 6 hours apart. That's half a period. And it's a quarter of a period between here and there. Okay? So that would be half of 6 would be 3. 3 from 4 is 1. 1 o'clock is your offset, and that would be your C. So we do have every parameter now. Now we're using, and we don't need all this stuff I was trying to do mathematically. It's so much easier to do it graphically. Okay. All right. Okay. Now. All right. James is here. Okay. We're just missing EJ and Aaliyah and Kamari. Okay. Good to have the rest of you here. All right. So now that we got C equal 1, we got Y is equal to 5.6 measured in feet times the sine of pi 6 times t minus 1 plus 5.7. Okay, there is your model. Okay, your mathematical model. Your taking forever. Okay, get some of these out of there. And here's Kamari. Good deal. So now we're just missing EJ and Aaliyah. All right, so we've got all 4 of our parameters. Going from max to min, that gives you, on the one hand, that's twice your amplitude, so that gives you amplitude of 5.6. That also tells you your vertical displacement, because the average of these will be your equilibrium point. That gives you vertical displacement, 5.7. Because you're half a period between these, the max and the min, and that's 6 hours, the full period would be 12 hours. So your period is 12 hours, and you know that the period is 2 pi over b, so your b would then be 2 pi over 12, and that would be pi 6. So we have our b then. And our offset here, if this is half the period, is 6 hours. A quarter of a period would be 3 hours, and your minimum, your equilibrium place would be 3 hours before your max. That would be at 1 o'clock. So that gives you 1 there. Okay. So we found the trig model, a function that models the data. The book does it with cosine, which is perfectly fine. Okay. Now, the second part says find the depths at 9 a.m. and 3 p.m. Okay? 9 a.m. would be somewhere right in here. Okay? But I wouldn't take the average of those two because this isn't a linear function. But how could you get it? 9 a.m., that's a t. Plug it in, plug it in. Y is equal to 5.6 sine pi 6 times, what did I say, 9 minus 1, that would be 8, plus 5.7. Okay? So this would be 8, and this would be 4/3, right? I know what sine of 4/3 pi is, don't you? 1/3 pi, 2/3 pi, 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi. Okay? But down here, the sign is negative there, so that would be square root of 3 over 2, right? So we'll have 5.6 times negative square root of 3 over 2 plus 5.7. Okay? I can do, say again? The A was 5.6. Is that what you said? Oh, the 8. I already took, okay. 9 minus 1 is 8. You had pi 6 of 8, right? Okay. I said 2 will go into this 3 times 4. That's where I got my 4/3 pi. Okay. Okay. And that's where I got my minus square root of 3 over 2. Well, 2 will go into 5.6 2.8 times. And with a calculator, you'll have to do the minus square root of 3. So 2.8 times negative square root of 3 plus 5.7. See what that gives you. Anyone got an answer yet? These little black boxes are pretty slow, aren't they? .8 times the negative square root of 3 plus 5.7. Say again? 0.85. That sounds pretty reasonable to me. Book got 0.84, but we'll give them a 1/10 of a foot. That would be in feet. That would be the depth of the water, and that looks pretty reasonable, right? Somewhere between 3.8 and this, okay? So it wasn't a good idea to take an average there because one steeper there, so yeah, that's reasonable. Now let's do it for 3 p.m. Now we don't have a clue about 3 p.m., do we? But what is 3 p.m. in number of hours since midnight? Here's EJ. We're only now missing Aliyah, sorry. Okay. Very good, team. By the way, everybody did get the first test, didn't you? Anyone not get it? Did you get the first test? Okay. All right. So, what is 3 p.m.? How many hours has that been since midnight? 15. All right. So we'll plug it in. Let's erase some of this stuff so we'll have more room to write. Okay. I don't think I need this stuff up here anymore. We've already done this. This is my tooth pulling time. Don't need that anymore. And we've already taken care of that and that. All right. Okay. So now we have y is equal to 5.6 times the sine of pi 6 times, and what do you say, 15 hours? Minus 1 plus 5.7. Okay, there was our model. Plugged in the value, 15. And let's see what we get. Now, this is not going to be one I know the answer of, because 15 minus 1 is 14. And, well, maybe I do. Wait a minute. This will be a 3 here, and that'll be a 7 there, won't it? So you got 7/3 pi. Yeah, we can do that one. 7/3 pi. Okay? Here's 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi, 6/3 pi, 7/3 pi. That is pi thirds, isn't it? And what's the sign of pi thirds? Square root of 3/2. So we can do this too. That's equal to 5.7 times the square root of 5.6. I can't read. Square root of 3/2, and the 2 goes into this, 2.8 times plus 5.7. Boy, sort of a piece of cake, isn't it? 2.8 times the positive square root of 3 plus 5.7. Shouldn't be too bad, should it? A little louder. 10.55 feet. Okay? Now let's see if that kind of makes sense. Okay? Notice what was our period here? 12, wasn't it? 12 hours. So that means 15 hours later should have been the same as it was 3 hours. And 3 hours was right here, something in between 8 and 11.3. Yeah, that's making a lot of sense. I would say, yeah, let's buy that one. 10.55, the book got 10.57. So they're off a little bit, but not too bad. Okay. Now, and you know why they're off, folks? If you notice here, they say B is equal to 2 pi over P, where P stands for period, and then they rounded it. So they introduced a round-off error that y'all are not introducing. So therefore, they introduced their own error here. I think ours is more correct. All right, now, this is a little bit tougher part. A boat needs at least 10 feet of water to moor at the dock. During what times in the afternoon can it safely dock? And unfortunately, I erased my graph here. It was just a makeshift graph, remember? We had it starting somewhere here, going up here, down here, okay? And, you know, that was about the middle of it. This was our 5.7 here. This is 3.4 here. You know, that kind of stuff. We need at least 10 feet to dock. So 10 feet is somewhere up here. And it says during what times can it safely dock? Sometime between here and here. Between there and there. But when do they say? During what times in the afternoon can it safely dock? Well, guess what? In the afternoon, because this only went till 12 noon, and it ended there at 1.2, somewhere right around here. So in the afternoon, it's just going to be these 2 points. Okay? Number one, we see that the 3 o'clock, yeah, it can dock then. Okay? And I'll guarantee you it can dock at 4 o'clock. So something before 3 until before 6. Okay? Those will be the times. We've got to figure out what they are. So what we do then, anyone have an idea? Okay, I need to erase some stuff. I think I'll erase this right here. Let's go back to our equation. Okay, but now the y is 10. 10 is equal to 5.6 times the sine of pi 6 times t minus 1 plus 5.7. Right? Because what we're looking for is 10 feet of water. And what we're going to do is do it for the morning hours and just add 12 to it, and that'll be that time in the afternoon. So whatever this is, say this would be 3 something in the morning, then it's going to be 3 something in the afternoon because the period is 12. So it hits here, then 12 hours later it'll be 3 in the afternoon. Or yeah, same thing here. So we'll figure for the morning and just add 12 to it and make it PM. And you will have it. Okay? So let's figure out what the T is. All right. Now, what you do is first subtract off the 5.7. Okay? And that will be 4.3, right? Is equal to 5.6 times the sine of pi 6 times t minus 1. Okay? Well, we'll divide by 5.6. So 4.3 divided by 5.6. Okay? I've got to find some place to write that. So someone do that quickly for me. 4.3 divided by 5.6. 0.767 is equal to the sine of pi 6 times t minus 1. Right? Well, let's take an inverse sine of both sides. Take an inverse sine of that number you have in your calculator right there. You know how to do inverse sine? It's usually the shift of the sine key or something like that. And by the way, that number better be something between this number. It had to be between -1 and 1. It was, so that's good. You can take an inverse sine of it. And what does that give you? 0.8754. Okay, that's in radians, right? What mode are you in? Check. What is that? Degrees or radians? I think you're anything but normal. No, never mind. Say again. What's that? Radians. Fantastic. So say it again what the number was. There's a maxim in mathematics. Know thy calculator. Never mind. Okay. What did you say the number was? You've lost it. Okay. 0.8754. Okay, we'll go with that. Okay. Then multiply that by 6 and divide by pi. Multiply by 6, divide by pi. That gets rid of the pi 6 then. Yeah. What we're doing, you're taking the inverse sine of this, you got that. So you got rid of the sine. Then you're multiplying by 6, dividing by pi. Right? So that's on this side now. You got it? And add a 1 to it from here. That should be easy. Okay, say again. 2.67189. Okay. Now, this is tricky. Forget about the 2 for right now. Multiply this by 60. The 0.678189. Subtract off the 2, right? Okay, well, here's the numbers. It's not that hard. 0.67189 times 60. About 40 some minutes. Say again? Say again. 40.3? Okay. So let's just say 40. So that's 2:40. 2:40 in the afternoon. That's the first time you can do it. Okay? Now, we got to get that second time. Now, here's the way without doing any more of the thing here. So the 2:40 in the afternoon is this one. Okay. We said, and that's the same as 2:40 in the morning here, right? This was 1 o'clock here, remember? So it's an hour and 40 minutes after the equilibrium position. So over here, it's going to be an hour and 40 minutes before the equilibrium position. Okay? And that equilibrium position was half a period, which is 6 hours. Right? So take 6. And that happens to be, the time here was 7 o'clock, remember? That's what we figured that time was. At equilibrium position was right at 7 o'clock, remember? We had that down here somewhere at one time. So remember this was 4, this was 10, halfway in between there was 7. So 7 o'clock, subtract an hour and 40 minutes from 7 o'clock. Let's make that 7 o'clock 6:60. Isn't that 7? Okay. Subtract from that an hour and 40 minutes. No, 2 hours and 40 minutes. Sorry about that. 2 hours and 40 minutes. Okay. And that would be 4:20. Okay. So we said from 2:40 in the afternoon. No. Yeah. 2:40 in the afternoon until 4:20 in the afternoon. Okay, that should be when we can do it. And let's see what they did. 2:42, yeah, right. And wait, they got 5:20. I must have subtracted wrong. Oh, yeah, it was 1:40. No, it wasn't. Yeah, no. It was 1:40. I said it right the first time. That is 5:20 in the afternoon. So, yeah, sorry, 5:20 in the afternoon. Because it was hour after it wasn't. It was an hour after, an hour and 40 minutes after equilibrium. So an hour and 40 minutes before equilibrium would be 5:20. Got it. So 2:40 in the afternoon to 5:20. Theirs is off a little bit, but not bad. They'd said 2:42 and 5:18. I think they're going to run aground, but we won't. Okay. Now, kind of a tough problem, huh?
Yeah, I wish they were doing that ever again.
You only see 3.
The whole class period. All this one problem.
Okay. Well, maybe there's a reason for that. You have another test coming up, remember?
Yeah, that's not going to be on there.
Not this one. That would be too easy.
You're not going to pull one of these.
I promise you, if you put that same problem on the test, I'll probably get it wrong.
I would too.
I would bank on it. No, I'm sorry. All right, we finished 4.5. Let's do vocabulary. Okay? One period of a sine or cosine function is called one blank of the sine or cosine curve. I know what word they're looking for. just a pretty simple word. Say again? Well, one blank of a sine or cosine curve. One period is called one cycle, exactly. One cycle of the cosine curve, sine or cosine curve. Number 2, the blank of a sine or cosine curve represents half the distance between the maximum and minimum values of the function. The what? Okay. That is the average between the two. What's half the distance between the two? First thing we did. Say again? Amplitude. Very good. Okay. All right. I can't hear. Number 3. For the function y is equal to a sine bx minus c. Now they do it differently than I did. C over b represents the blank blank of a graph of the function. We've been calling it just c. They call it c over b. They put the b inside the parentheses. We put it out. Phase shift of the graph of the function. And number 4. For the function y is equal to d plus a cosine bx minus c, d represents the blank blank of the graph of the function. Vertical shift, you got it. Good deal. Homework exercises. Do any of the odds 5 through 17. Do any of the odds 19 through 29. I would do 19 to 25 and then 27 or 29 or both. Okay, do any of the odds 31 to 37. Any of the odds 39 to 59. Any of the odds 61 to 65. Any of the odds 67 to 71. Do either 73 or 75 or both, either 77 or 79 or both. Do 81. Then do any of the odds 83 through either 83 or 85 or both. And then do any of the application problems, 87, odd 87 through 93. Pick the ones that either you like best or look closest to your major or whatever. Then exploration, not a bad idea to look at 95, 97, think about 99, or 101. And that's it for 4.5. Okay? Let's pretty sure we were, wait. Already exited. May not do. Okay. Let me go back there just briefly. Let's see. From current slide. I forgot to go to the next slide. Okay. This was telling us what to do. This was do it. They say begin by graphing. That's the part I left out. I drew a quick little graph there. Actually draw them, and then what they did was connect the points, and maybe this would help you see if indeed those are your maximum min, halfway between that is the amplitude, the average between these two is your equilibrium position, the time-wise, the distance between those two, that's half a period on the time axis. Full period would be twice that, and then to get your phase shift would be a quarter of the period between here, and we found that to be somewhere about here, and it would be 1. That's what we found it out to be. So if it's helpful to draw the graph, draw the graph. Okay. They use the cosine model where we use the sine model. Doesn't really matter. The only thing that made it a little easier for cosine is then you knew the phase shift was exactly 4 because that cosine starts there. Okay. So you're over 4. Okay. And then this shows how you got them. Amplitude is half the max minus min. Yeah, half the difference between those. And they got 5.6 just like we did. Your cosine function completes half a cycle, so they did the period next. Between the time of minimum and time of maximum, that's what we did. That was 6 hours, so your period was 12 hours, and then b is 2 pi over p, and they rounded it. That's where they made their error. If they had left it as pi 6, that would have made a lot of sense, and they wouldn't have had the errors they introduced later. And because it occurs 4 hours after midnight, that was our C over B. We called it C. They called it C over B. And that introduced then another issue, because then they're using B, which they rounded to use C. If they had just used it like we did, it would have been a lot easier. Okay, moreover, because the average depth is that, it follows that the D is the average between the max and min. So it was 5.7. That gave them that formula. We use sine, which has the same A and the same here. And rather than using this, we use pi 6, pull it on the outside, minus 1. It made everything a lot easier. And then between 9 and 3, we put in the 9, and they got 0.84 feet. The reason they got 0.84 rather than 0.85, they rounded there on the 0.562, and they rounded on the 2.094, okay? And then when they put 15 in, they rounded to this. We got 10.55. Ours is more precise, okay? And then using a graphing utility is how they did it. We did it algebraically, and they got it between those two. And what they did with the graphing utility is put this function in, or the one we used, and then drew the line at 10, and then picked those values off, and that gave us 14.7, 17.3 multiplied by 60. The 0.7 by 60, you get 42 minutes. So 2:42 in the afternoon, and 17.3 would be 18. That gave them the 5:18. But again, because they use these round off numbers here, theirs is also a little bit more than ours is. But, okay, that then finishes. Okay. All right. It was a long problem, but kind of thing you need to practice on doing. I'll tell you, you will see at least one similar to that. Not the same problem. Yeah. Say that again. Okay, I can't. My hearing's so bad. Oh, your calculator. This, you don't have a graphing calculator, do you? Yeah, that's on a graphing calculator. But that's where it intersects this line here. That point and that point. If you have a graphing calculator, that's what you're doing. Okay. I don't have one either, but I've used them before, and that feature's on there. Okay. All right, we only got a minute. Sorry. Let's start from current slide. And let's at least get started. We're still in trigonometry. This 4.6 is the graphs of the other trigonometric functions, which involve what? We've done sine and cosine. What's the other trigonometric functions? Been too long, hasn't it? Yeah, tangent, cotangent, secant, and cosecant. Exactly. Okay, so what we'll do is sketch the graphs of the tangent functions, sketch the graphs of the cotangent functions, sketch the graphs of secant and cosecant functions, and then we'll get to one other, and be sure you put the P in there, the damped trigonometric functions. Okay, and that's how we'll proceed. We'll start with the graph of the tangent function next time. Okay, well, we are basically out of time. sorry that one took so long, but it's, I think it was worth it to get those down. And we only missed Aaliyah, but we did miss her. All right. Have a good weekend. I'm sorry, yeah. Okay, you did get it? You did get it? Okay. Sure. I just have very few office hours, but yeah, you can come. Office hours on Monday and Wednesday are 3:15 to 5:15, and Tuesdays and Thursdays is only 10:45 to 12:30.
Sorry, my throat's kind of.
Oh, that's all right.
So that's why I can't talk loud.
That's okay.
I was late today because my car was flat.
Oh, sorry. Yeah, it happens. What's that?
I thought the test was due last Tuesday.
No, you just got it last Tuesday, didn't you? Didn't you
No,
just?
I wasn't here.
Okay. Do you have it now?
Yes.
Oh, you do have it. Okay. It's due a week from now.
Oh.
Yeah.
Alright.
That gives you, yeah. Okay. Oh, that's right. It was last. Okay.
I'll have mine to you this next Tuesday.
Okay. That would be great. I'm not so picky on the time. Just get it in. Yeah. All right. Good idea. Uh-huh.